Hi, my name is Kai, and welcome to Tutoring on the Go. So today, we're going to talk about trig ratios. And trig ratios are pretty simple once you practice them. The most important thing you need to remember is this little mnemonic device. SOHCAHTOA. SOHCAHTOA is just the little thing to help you remember it. So means sine of an angle, we'll use theta for this, is equal to the opposite of the angle over the hypotenuse. Cosine is equal to the adjacent over the hypotenuse, and tangent is equal to the opposite over the adjacent. So what would this look like in practice? So let's say I had a right triangle here, and we have these two angles. We'll say angle A and angle B. And we have the lines length x, length y, and length z. So what we do here is for sine of b would equal to x over z, because it's the opposite over the hypotenuse. And cosine of b, y over z. So what would tangent of b be equal to? You're gonna write this out, and then I'm gonna give you a few moments to solve it on your own. So pause the video and solve it. Okay, so if you said it's equal to x over y, you'd be correct. So there is something interesting you also might want to note here. Sine of b is equal to cosine of a, and cosine of b is equal to sine of a. This is something very important. So I'm going to do a practice problem quickly. I'm going to ask you to find the sine of one angle. So here we go. So we have a triangle of length 25 and 24, and this is our angle. How do we find sine of theta here? So I'll give you a few moments to pause the video, and then I'll explain how you solve this. All right, so there's a few ways of solving this, but I'm going to go with the simplest one, which uses the Pythagorean theorem, which states that if this is length x, then that would mean x squared plus 24 squared would be equal to 25 squared. And if we do the math, that means x would be equal to 7 in this case, if you've done the math correctly. So sine theta is equal to 7 over 25. Theta is basically it's just a variable, in case you're wondering. It's just a variable. We use the Greek letter theta when we describe any value of an angle we don't know. All right, so there should be a worksheet provided to help you deal with the rest of these problems. One thing that you can do with a triangle like this is, let's say we have this angle here. I'll just say it's angle theta. Currently, we have arc lengths of x, y, and z. What we've learned is that sine of theta would equal x over z. However, there's an interesting thing you can do. This means that theta is equal to inverse sine x over z, which you can write as this, or you could write as arc sine. Now, this principle also applies to cosine and to tangent. This is very important. This is how you find angles from the lengths of two different sides of a triangle. I'm going to give you a word problem. What I want you to do is we're going to draw one more triangle. We've got like a wall here, we've got like a brick wall, and then we have a ladder. My art skills are just going to make this more confusing. So we have a wall and a ladder leaning against the wall. Currently, we know the ladder is, let's say, 5 feet long, and we know that the ladder is also forming a right angle right here, and it is currently 3 feet away from the wall. So at what angle is the ladder leaning against the wall? So I'm going to give you a moment to figure out how to solve this. All right, if you said that angle theta here, let's just call it theta, is equal to inverse cosine of 3 over 5, then you'd be correct. Trig ratios, as you can see, is just a lot of pattern recognition, and it comes down to just looking at a right triangle and being able to tell immediately how to get every angle and every missing length value. And the tools we can use to that, just to recap, are sine, cosine, and tangent. And we can use the Pythagorean theorem to find a missing length. And if we need to find a missing angle, we can use inverse sine, inverse cosine, and inverse tangent. So, thank you for watching.